Okay, so hello everyone. So you guys can see my screen, right? Hopefully. Yes, good. Okay. So welcome to my class. I guess this is also first day of your semester. So we're going to learn the civil engineering or environmental engineering 5662. So this is the air pollution control methods class. And in this class, we're just going to get a brief introduction of this class and get to know the syllabus and also some background understanding of why we're going to learn this class. All right, so I'll just, at the beginning, I'll briefly introduce myself. So my name is Wang. I'm the lecturer of this class. So in terms of calling me, you can feel free to call me Dr. Wang, or just call me by my first name, Yang, because actually it makes me feel younger if you call my first name here, okay? So I joined S&T last year in 2019. So 19. So apart from this class, 5662, I'm also teaching the 2601. That's the fundamentals of environmental engineering. It's an entry-level class for the environmental engineering, actually. So I think in that class, you also get some exposure of the environmental engineering concepts. You learn about some air pollution aspects, right? So in this class, it's going to be a more in-depth class that's going to show you what are different types of air pollutants and how we can control the emission or control the basically how we're going to learn about the mechanisms of the production or formation of these air pollutants. Okay, so I'll start with the boring things first. All right, so what is our course objectives? So basically, by the end of this course, you'll have a deeper understanding of the mechanisms of air pollution generation. So we're going to learn how they're being generated, right? And also we'll be able to design major types of air pollution control technologies. So the course is called Air Pollution Control Methods. So we'll focus on the methods of these pollution control techniques, right? So in terms of air pollutants, we're going to learn different types. So they may include particulates, volatile organic compounds, sulfur oxides, carbon monoxide, and nitrogen oxides. So there are going to be quite many of them, and we'll actually learn in this class why these are very important air pollutants. So we'll be able to answer questions like, let's say, where to build a power plant. Is it going to be East Coast or West Coast? For example, if you have a say in this problem, let's say people want to build up a newest power plant, which actually generate a lot of air pollutants. If you have the decision to build it, whether at East Coast or West Coast, we're going to build it, right? So this is going to use some knowledge in terms of the air movement of our Earth. So I'll just tell you the answer now. So if you can decide, you should build it at East Coast. This is not because we dislike the people on the East Coast. This is because for the latitude of the United States, actually the dominant wind direction, the dominant wind is coming from the west. So if you can build a pollution device, you want it to basically want the wind to carry all of these pollutants to the ocean, right? You don't want to bring them inland to impact the cities. So also know how does a particle move under different types of forces, for example, the gravity, centrifugal force, electrostatic force, and also how to remove these particulate. For example, sulfur oxides, nitrogen oxides, volatile organic compounds, or even carbon dioxide. So there's a lot of debate about whether we should treat carbon dioxide as a pollutant, right? Because if we really make that decision, let's say carbon dioxide is a pollutant, we have to control it And we know that for all of these combustion process, let's say we drive a car, we generate electricity, generates millions of gigatons of carbon dioxide every year. So it's posing a huge impact on both our economy and also on our climate. So we'll also introduce these issues in our class. And also we'll learn how we're going to measure the concentration of these air pollutants. Okay, we'll conduct some cost analysis, very basic cost analysis, because you're going to spend more time in your group collaborations to look at how expensive are these different types of air pollution control devices. So basically in your term project, you're going to design some pollution control devices and come up with the cost for constructing that, including both the capital cost and also the operating cost. Okay, so any questions? You know that right now I cannot really see your face. So if you have any question, you can feel free to type them in the chat, right? So I can, if it pop up, I'll just go through that. Or you can just unmute your microphone so I can hear your voice, okay? So in terms of the textbook, we're going to learn from the air pollution control design approach, Cooper and Alley, 4th edition. So some of you also asked me whether you can use the 3rd edition. So in terms of the course contents, I would say you can, because the contents are basically the same. But for the homework problems, since I will be assigning problem numbers at the back of each chapter, so you probably want to at least have a friend or have a few friends who have the 4th edition, so you know, excuse me, so you know which problem we're talking about, okay? So in terms of grading, we have one midterm, one final. So the final exam will be comprehensive. The midterm will mainly cover the particulate matter, which is one type of the air pollutant, okay? Particulate matter here. And so right now I'm thinking of holding these exams on Zoom. So basically it's going to be similar to our normal classes. So I'll make these exam problems available, let's say 5 minutes before the class, so you can work on that, and then basically write the answer on a piece of paper, and at the end of the class, you'll take pictures and upload it to Canvas, okay? So I think if you're not familiar with uploading these materials, you probably want to get familiar with these basic techniques, so we can better deal with the exams. So I'm still thinking about this. I'll probably also listen to other professors. So if they think that take-home exam is better, so we can also design some problems for take-home exams. So these are the exams. So in terms of the project, so there's one more student. Okay. So in terms of the project, you guys will be divided into 4 groups. So based on the number right now, I think each group will have around 8 students. So each of you will have probably 7 colleagues, right? So you will design a air pollution control device, like the entire control system for a coal-fired power plant. Okay? So to control the carbon dioxide, sulfur oxides, and also come up with a cost analysis for these devices. So we want to be as in detail as possible, right? But for each group, we will use different parameters. So you guys can just focus on your own settings of these control devices. So I'll introduce the project and also the group assignment during the 3rd week of the class. Okay. So we'll have quite many weekly assignments. So every week we'll have a few homework problems, and so that will take around 25% of the total score, right? So finally, we have the participation. I know that for online classes, it's a little bit difficult to basically count the participation. So luckily I got to know that Zoom also have a feature called Zoom pooling. So we can try that out throughout our class. So since we have got to here, let me just quickly try this out, okay? So if I click the pool, I guess you guys can see my pooling, right? So here I have a quiz question, right? So you can choose that. You can finish this in a limited period of time. So I'll just launch the pooling. So you guys can choose. We'll have, let's say, 20 seconds for you guys to work on this problem, okay? Yeah, I probably shouldn't. Okay, yeah, I see it's increasing dynamically. So we still have 3 students who haven't responded yet. Okay, 2 more students. Let's finish at 1 minute, okay? All right, I'll finish. So I'll share the results. So you guys can see the results, right? So the correct answer is 105. If you do the calculation. So it's good that some of you didn't choose the third option. So if you didn't get this correct, don't be too worried, because for our exams, that will be open book exams, so you can refer to any material you have. For example, textbook or even online materials. So if you want to do some calculation, you can use your calculator, or you can even type in your equations on like a Google Chrome or Wolfram Alpha, right, to get the answers. So for those who did find the correct answer, congratulations. All right. So I think the Zoom pooling indeed works. It's actually quite effective. Okay. So further, stop sharing the results. Minimize this. And then regarding the homework assignments, it's going to be once a week. So every Friday, I'll make these assignment problems available on Canvas. So we will have occasional week off, basically to celebrate, for example, the midterm, right? So I know that during the midterm time, you also need to prepare for other classes. So to reduce the burden, I'll just make that homework-free week. Okay? It will also be due by the beginning of the next class on Friday. So you have 1 week time to work on the homework problems. So in terms of the requirements, the homework should be handwritten. You need to write out all the steps, also comment on how you solve the problem. So if there is a numerical answer, try to circle it out. So it's going to be easier for me to identify the answers. So unfortunately, we don't have a TA for this class. And so basically, I'll be grading all your homeworks. So if you can do this, that'll be very helpful, okay? So all the submission will be done on Canvas. So you also need to basically name your file correctly. So you can use the, I would recommend you to use the naming convention of last name, first name, assignment, and number, right? If you have assignment 5, you just replace that X by 5. Okay, so it's easier for me to recognize your name. So try not to use the file name, for example, homework, work, my work, test, something like that, right? So regarding the projects, so as I said, I'll be introducing them on the 3rd week of the semester because some of the concepts, we won't learn them until the 2nd half of the semester. So I would say, since you guys can work on some contents for the project, you probably want to start early, okay? So I also always get complaints that basically you guys don't have enough time to work on the project. So if you actually start earlier, you will have more time to deal with those questions. Additional contact person. So I'll do my best to solve any problems you have. But if there is a problem that I can't resolve, for example, you really dislike me, okay, so you regret taking this class after a few classes, all right, and you don't want to talk to me, so you can talk to Dr. Joe Burke. He's also the department, so maybe he can help communicate, or he can help resolve these questions you have, all right. So finally, I want to say that academic dishonesty is not accepted, and this applies also for our class during this pandemic. I know that during the online learning, things will be getting quite complicated, but I hope that, I mean, we all engineers can stick to the rules or stick to the, basically our beliefs, right? We'll work on these problems all by ourselves. I mean, except for the team project, we want to work with our teammates, right? So here, I would say it's a rough schedule of our class. So our class is going to be every Monday, Wednesday, and Friday. So we're going to learn the classes in synchronous form, which means that we'll all log on to Zoom and then we'll learn through the contents. So well, if you have any questions, you can feel free to speak up, unmute yourself, right? And ask questions. So don't be worried that I mean, interrupting the classes or anything. I might interrupt anytime by something else because I have a baby at home, so who knows, right? So sometimes the baby might just cry, okay? For example, here I'm also labeling out the classes that. So basically, the time that we won't have classes because we have a few vacations, right? We have the also the fall break and also the Thanksgiving. So basically, the gray areas are the classes that we won't be are the time that we won't be having classes, and we will have a few recorded lectures at the end of this semester, because at that time you can have more time flexibility to work on the term project and also prepare for the final exam, all right? So we will have the presentations for our term projects during the December 7th and 9th, 2 classes. So each class will have 2 teams presenting, right? So you guys will be grading each other's term projects, right? So we'll leave that time open. And right now, I have to say that we know which week our midterm will be, right? It's going to be the week of October 19th. But it really depends on you guys. So if you have a preference of either 19th or 21st, you can do that. So we can also discuss about the options later on, okay? So I'm also showing the class contents. So I'm also showing the class contents for each week. I know that sometimes it's going to be a little bit difficult to stick to all of these detailed chapters, but I'll try my best to stick to this schedule. And so if you want to refer to the textbook, so the final column here shows which chapter of the air pollution control Cooper and Alley book we're talking about, right? So you can use the textbook to basically catch up with the class contents. So I think that's it for the syllabus part. So any questions until now? So I guess maybe we can try to use the reaction. So if you're good, you can use the reaction of a sum up. Okay. Good. Okay, nice. All right, yeah, let's continue. Go to the contents of our class, all right? So as you guys know, our class is called Air Pollution Control Methods, right? So what is air pollution? Well, what are air pollutants? Okay, so I have to say that air pollution isn't something very new, but actually a lot of research or new research are popping out in recent few years. For example, we all know that air pollution is bad for human health, right? It is actually last year, you can see this news thread, right? It's last year, 2019 in November. So this is the first time that people find air pollution. Actually, one type of the air pollutant is linked to the brain cancer. Okay? So the specific air pollutant we're talking about are the nanoparticles, which are the, we also call them as particulate matter. All right, so what it's saying is that tiny particles produced by these motor traffics, let's say car engines, can invade the brain and carry carcinogens. So basically, if we inhale them in, they can penetrate through our cell membranes and also lead to some very negative effects, health effects, for example, brain cancer. And also, we know that for these particulates, the most direct way is to deposit onto our respiratory system, let's say lungs, right, and cause allergies or asthma. So this is very active area regarding the air pollutants. So to be more related with the current situation, so what people find out is that in general, it seems that air pollution is related with the number of cases for COVID-19. So what these two graphs are showing is the COVID-19 cases, so COVID-19 cases per 100,000 people, and the annual concentrations of PM2.5. So PM2.5 are basically the particulate matter, PM, that are below 2.5 micrometers. This is PM below 2.5 micrometers, okay? So this is showing two graphs. So on the left-hand side is showing the number of COVID-19 cases per 100,000 people. And on the right-hand side is showing the basically the pollution, a map of pollution, how polluted the area is. And we're talking about Netherlands, okay? So by comparing these two graphs, you can see that a lot of areas are matching each other. For example, here, we generally have more pollution, right? For example, here, we also have more cases and also more polluted area. There are a few areas that does not agree with this pattern. For example, here, the area is quite clean, but you see there are more cases here. Maybe also here. Okay, so people are saying it seems that there's an active correlation or some kind of correlation between COVID-19 and the air pollution. So does that mean the air pollution will lead to more cases? For example, we live in Rolla. We know that the air quality in Rolla is pretty good, right? But let's say if we live by an industrial plant in Rolla, so let's say if we live in an industrial plant in Rolla and we have pretty bad air quality in our apartment, so does that mean we have a higher chance of catching COVID-19? So what might be the reason? So here, I will launch our second poll here. So we have a minute to work on that. I'm giving two options for you to look at what might be the potential reason for this happening, okay? Yeah, if you find that the polling doesn't work for you, you can probably let me know in the chat, right? So I think there's a way that we can work this out, okay? So, all right, I'll end the pooling and then share the results, okay? So there are two options. So one is that COVID or the SARS-CoV-2, which is basically the virus that's causing this disease, may be carried by air pollutants, or the polluted areas are often more crowded. So I have to say that for the first one, people are still working on that. So there's no clear evidence showing that the SARS-CoV-2 virus can be carried by air pollutants. Because if we consider the size of these viruses, typically they have a size of around 60 to 150 nanometers. Okay, so nanometer is basically 1 multiplied by 10 to the negative 9 meters, right? So they're very, very tiny, I would say, particles, okay? But when we're talking about air pollutants, so we're talking about, let's say, particulate matter, for example, particles, right? We're also talking about sulfur oxides, nitrogen oxides. So these gas molecules are much smaller. So they won't be able to carry these SARS-CoV-2 viruses. But in terms of the PM, right now there's no clear evidence showing that the PM can carry these viruses and then get people infected. So it is more likely because of the second reason, because we know that urban areas are more polluted. That's why I would say St. Louis and also Kansas City will be under higher pollution levels, right? But at the same time, these polluted areas or urban areas are also very crowded. They're populated with people, so there are more interactions among people, right? So it's easier for the transmission of the virus. So that's why we're going to choose the second option for this question here. So I would say that this is kind of an example of showing two things happen together, but they might not have a direct causal relationship, right? So they might be correlated with some other reason. So this also applies for us, right? So you know that for the future engineering, we have to deal with a lot of these analysis, and we don't want to judge or make our decision so quickly just by the appearance. We want to better understand what is happening behind, right? So also because these urban areas, we know that because of more population, the hospitals will also have a higher chance of getting too populated. So they might not have enough beds, right? So this will basically cause a higher transmission or even higher deaths among these patients there, right? So these are basically some applications of our knowledge on air pollution and how they may be influencing our daily life. But let's get back to our question here. So what is air pollution, or what are air pollutants? So according to a more rigorous definition, so here I'm showing the Florida Administrative Code. So here they define the air pollution as the presence of the outdoor atmosphere, right? So we're specifically talking about the environment outdoors. Although we know that people spend more time indoors. Actually, on average, for each American, they spend around 90% of the time indoors. Okay, just think about how much time we spend during our entire life indoors, right? So that's why the indoor air quality or indoor environment, indoor pollution is also pretty important. But here we're talking about outdoor atmospheres, okay? So the air pollution is something in the outdoor atmosphere of any one or more substances. We're not talking about one, but we're talking about multiple species or pollutants, okay? So they're in the quantity which are or may be harmful or injurious to human health. So if we know that they are harmful, for example, the particulate matter, that may lead to brain cancer, that may lead to asthma or allergy, we know that it is an air pollutant. But if we don't know about it, they are maybe harmful, there are also air pollutants. For example, carbon dioxide, right? You know that carbon dioxide is not really harmful. We're inhaling carbon dioxide all the time. But if they may cause global climate change and cause a harmful effect onto the human health, they should also get categorized as the air pollutant, right? So we're not only talking about the human health. So it may also put an impact on the animal or plant life, okay, or even properties. Okay, so it's not talking about lives. We're also talking about properties. And the most direct example is, let's say, sulfur dioxide. Okay, we know that sulfur dioxide can, when they get emitted into the atmosphere, right? So they can react with water, right? And also get oxidized to form sulfuric acid. So this is kind of a ultimate fate for the sulfur dioxide in the atmosphere, right? So why do we care about sulfuric acid? Sulfuric acid is pretty strong acid, right? So once they get emitted into the atmosphere, they can basically pump up. Let's say this is our stack, right? We are generating sulfur dioxide into the atmosphere. So once they get emitted, they might help the formation of the clouds, right? So we know that sulfuric acid can dissolve into the water very quickly. So they're going to form these cloud droplets that are quite acidic. And finally, if this cloud meets with other clouds, we know that we're going to generate rainfall, right? So basically the rain droplets are going to contain acid, and we call this as acid rain. So acid rain might not put a direct impact onto human because we can always carry an umbrella, right? But if we talk about the constructions, I know that there are a few civil engineers also in our class, right? So if we're talking about constructions, so this acid rain rain droplets can corrode the surface of these constructions, right? Cause damage to the property. So that's why sulfur dioxide should be categorized as an air pollutant. And of course, sulfur dioxide can also cause some damage to our respiratory system. So basically, if we inhale them, they will also cause some health effects. But by combining these two effects together, sulfur dioxide is an air pollutant. Okay? So we're talking about the damage to human health, animal, plant life, property. So I think the final one, so this one is basically helping broaden the air pollutant to a much wider substance. So if that substance can unreasonably interfere with the enjoyment of life or property, okay? So not only harmful to our health, but if it interfere with the enjoyment of life, it's also air pollutant. Okay? So you can see that based on this kind of definition, there are just so many types of air pollutants surrounding us. Carbon monoxide, right? Carbon monoxide is toxic. If you talk about the vapors of the gasoline, they are also air pollutants because they may burn, right? And also cause some damage to either human health or properties. So there are just so many of them. And where should we start, right? So luckily, people have defined or have been able to find out what are the most important ones, because when we face a problem, we'll also start from the most difficult ones, right? So people find out 6 very important air pollutants, and we call them as 6 criteria air pollutants, okay? So they're important, not because they're very toxic. So it's actually a combination of their quantity and toxicity. Okay, so they may not be very toxic to human health, because if you think about very toxic materials, say radioactive materials are very toxic, right? So theoretically, they should be categorized as air pollutants too, but they're not emitted in large quantities. So we're also talking about the quantities. So we need to identify the pollutants that's being emitted every day from almost all of the industrial processes or human processes, right? So, and also they need to be toxic. So based on this criteria, we can find out this 6 criteria air pollutants. So they will include particulate matter, sulfur dioxide. So we'll also call them as sulfur oxides because basically the sulfur dioxide can easily get reacted into sulfur trioxide when they're emitted into the atmosphere, right? So we'll just use SOX here. X can represent all different types of values. So nitrogen dioxide. So we'll also use NOx to represent that because nitrogen dioxide have all different types of relatives. For example, nitrogen monoxide or N2O5 or N2O. So all of these different types of relative molecules when they get emitted into the atmosphere, right? So we also talk about carbon monoxide. It's also a criteria air pollutant, lead, and finally ozone, right? So we have 1, 2, 3, 5, 4, 6. So these are the most important air pollutants. So we'll just briefly introduce them one by one. So in terms of particulate matter, as I have introduced earlier, we'll also use PM for short. And during the class, you can also hear me calling these as aerosols. Okay, so basically they have the same definition, right? So particulate matter equal to PM equal to aerosols. So when you hear me talking about aerosols, they just mean particulate matter, okay? For these PM, the major health effect or the major negative side of these species are actually it's going to cause the negative effects onto the human respiratory system. So we're talking about human health. And also the respiratory system. For example, it can lead to asthma or allergies, right? Once these particles deposit onto our lungs. So you can also hear me saying about PM10 or PM 2.5, right? So some people will also add a dash in between. Either way works, right? So these value here represents the size. Okay, PM10 means everything below. I should probably just use below 10 micrometer. And PM 2.5 means below 2.5 micrometers, okay? And in terms of sulfur dioxide, so it has actually the same effect as the PM in terms of the respiratory damage, okay? So at the same time, as I mentioned earlier, sulfur dioxide can react with water, right? And then we're going to basically form acidic rain or acid rain. And if with oxygen, we're going to form sulfuric acid, so acid rain. So the same for the nitrogen dioxides. They can deposit onto our human respiratory system, cause these asthma, allergy, but at the same time, it's same to the sulfur dioxide. And we're going to form nitric acid. So both of them will contribute to the acid rain, cause damage to the properties. Okay, so for carbon monoxide, it is a little bit different, right? So it's not going to cause these allergies, but what it really does is it's going to combine with our red blood cells. So we know that the red blood cells carry oxygen to our human body, right? So once these cells are exposed to carbon monoxide, So it's going to replace the oxygen by these carbon monoxide. So it's instead of transporting or sending these oxygen molecules, the red blood cells are going to send carbon monoxide, and we know what's going to happen, right? So basically our cells are going to break down. And in terms of lead, it is one type of the heavy metal. So by calling them heavy metal, we basically mean its molecular weight is pretty high, right? Molecular weight, right? So it has a high molecular weight, and also because it's quite inert, so it's going to accumulate into our human body, especially in some organs. For example, brain, kidney, and let's say heart, okay? And this is a very severe issue, especially for young children, because children are developing their organs, right? And then once we have these heavy metals in there, it's going to be very difficult to remove them, because basically the immune system or the human body system cannot get rid of these inert materials from the human body. Okay? So finally, it's the ozone. So ozone will have the same effect in terms of the respiratory system, but also ozone is a strong oxidant. So ozone can react with a lot of daily properties that humans have. Okay, so for example, it can oxidize the tire. So there was one time that California was very polluted because of the industries, and also because of the strong sunlight there. They generate a lot of ozone through reactions, and I will talk about the reactions later. So from these strong oxidants, basically they will oxidize the rubber in the tire and then cause the damage to the tire. It becomes very brittle. It's very easy to damage these organic molecules. Okay, so this is property damage. Property damage. All right. So among these 6 different types of air pollutants, we can further categorize them. All right. So the first 5, we can categorize them as primary air pollutants. So the primary word here doesn't mean that they are more important. It means that they're directly generated from human activities. And one very common example is the coal combustion. So coal combustion or fossil fuel combustion generate particulate matter, right? Sulfur dioxide, nitrogen dioxide, CO, right? Because if they're burned incompletely, we're going to generate carbon monoxide, and also lead, because coal particles have a lot of these heavy metals. So we can generate all of these air pollutants from one single step. So that's why it's called a primary air pollutant. And for ozone, it is called a secondary air pollutant. Okay, so the reason why we call it secondary is because it's not directly generated, so it's indirect. So the way it's generated is based on, basically based on the nitrogen dioxide or nitrogen oxide species. So what happens is, let's say nitrogen dioxide under solar radiation, this means the energy of a photon, right? Under solar radiation, it's going to get dissociated into an oxygen radical and nitrogen monoxide. And the nitrogen and the oxygen radical can combine with oxygen molecule to form ozone. So basically, without the nitrogen dioxide, we won't have the issue of ozone there. So that's why it's called a secondary air pollutant. Although it's also emitted by large quantity, and it has certain amount of toxicity there. So the same process can also happen to volatile organic compounds. Organic okay, or VOCs. So the VOCs can also react with solar radiation, and they can also emit oxygen radical. And these oxygen radical can combine with the oxygen molecule to form ozone. So the VOCs and nitrogen dioxide or nitrogen oxides, they are primary air pollutants because they're directly emitted, but they will indirectly form these ozone molecules. So ozone will be a secondary air pollutant. Okay, so we have first the definition of the criteria air pollutants because they are quite important, right? Even for them, we can divide them into or categorize them into primary and secondary air pollutants. Okay, so in this class we're going to deal with these air pollutants one by one, and we'll start with the particulate matter. Okay. So of course, there are other types of air pollutants. So as we have mentioned, the definition of the air pollutant is very broad, right? So we basically cannot designate just a few air pollutants. There is a long list of these air pollutants. So there are also a few very important ones, but not to categorize them as criteria air pollutants. For example, heavy metals. Right? So we show the example of lead because it's very important. So there are also species, for example, arsenic, right? Mercury, right? Copper, so on, okay? So we introduced a little bit about volatile organic compounds like VOCs. So a major example can be formaldehyde. So it's composed of carbon, double bond with oxygen, and 2 hydrogen here. So this molecule is being emitted in large quantities when you get new furnitures. They're being used in adhesives, right? New furnitures or newly furnished homes. Okay. So I hope that my handwriting is clear enough. So if you don't can't recognize anything here, just let me know. So, but VOCs actually contain a lot of other species. For example, benzene, right? Propylene, and combustibles. For example, the volatiles coming out of the gasoline, right? Whenever we go to the gas station, we can smell something. So those are combustibles. And so basically, if we talk about the entire emission, total emission of the VOC, I would say it's quite comparable to some of these species here. For example, ozone here. But VOC is not categorized as one type of the criteria air pollutants because VOC just have so many of them, right? And when we try to regulate something, we have to designate a clear name or a clear species of these air pollutant. So that's why we cannot categorize the VOC as a criteria air pollutant, although the total amount of these species may be very high. But if we break it down to a single species, then the amount, for example, for the formaldehyde might not be very high there, okay? So other types of pollutants, for example, the radioactive materials. For example, radon. You know that a lot of houses, apartments, they have radon inside. So radon is a radioactive material. It's going to be bad for human health. And unfortunately, there isn't a way to remove radon. So you always need to look for a place that's away from different types of natural rocks, right? So radon concentration will be much higher when we talk about the underground mines. Okay, so in our school, actually have a nuclear engineering. There are a few research groups just trying to measure the activities of these radon species. Okay, so here we talk about the 6 criteria air pollutants, and here I'm showing a long-term observation of these air pollutants. Okay, so we introduced 6 criteria air pollutants here. We know that there's VOC here, okay? Which means that we only showed 5 of them here. So which one is missing? If we think about all the species, we have SOx, NOx, PM. So we have PM10, which are particles below 10 micrometer, CO, and lead. So the one that's missing is ozone, right? So why didn't we show that? So if we further look at the y-axis here, know that it's not very clear. The y-axis is emission rate, okay? So this is what people measure downstream of the industrial plants, right? So these are all emissions. We know that ozone is a secondary air pollutant, so there's no way that these ozone are being emitted by these industrial plants, right? They're formed by secondary reactions. And we cannot measure these secondary emissions because they may happen everywhere. For example, if we have a place that's raining, then basically we don't have a emission or we don't have solar radiation. So the reaction of these VOCs and NOx cannot happen, right? So there's no way we can quantify the emission of the ozone. But based on the trend of all of these pollutants, we see a very clear trend, right? So we know that something happened during the year of around 1970s. So all of them seems suddenly decreased, right? So what might be the reason? So I'll launch the third pool, right? Stop sharing. Share the third pool here. So what happened during the year of 1970s? Let's work on this problem. All right, so I'll stop here. So most of you are correct, right? It's because of the funding of the EPA. So EPA is the Environmental Protection Agency, right? So if you really track this period, actually the economy is pretty good during this period of time. And we didn't have a major war. There may be small wars, combats taking place, but it's actually mainly because of the funding of the EPA. So what happened during that time is, so basically President Richard Nixon proposed the establishment of EPA on July 9th, 1970s, right? So, let's see. Seems that my app is freezing, but we're getting to the end of the class. So basically, it's during the 1970s when we had the establishment of these environmental protection agency that led to more regulations. So you can see that how the governmental efforts can really protect our environment, right? So if we can set up some initiatives in these environmental protection laws or environmental protection regulations, we can really try to solve for these. We can really solve these environmental problems. Okay, so that's the end of this first class. We may have a few information, but let's talk about this in our next class. Okay, so finally, as a review, in this class we learned about the definition of the air pollutants. We know that it's quite close to our daily life. We introduced the 6 criteria air pollutants, right? And we also talk about the funding of the EPA. So we will learn how these actually affect our air pollution scenarios later in this class. So that's all for this class. Any questions, you can feel free to email me. And if you have a class afterwards. You can probably need to catch a time and then go for that class. All right. So thank you all for attending. All right. Talk to you on Wednesday.